Our Changing Planet Chapter 7, Almost Everyone's Guide to Science, John Gribbin. By human standard, the Earth is big. It has a diameter of nearly 12,800 km and a circumference in round terms of 40,000 km. But most of the things that affect us directly take place in a very thin layer near the surface of the Earth, the crust of the solid planet, and the thin blanket of atmosphere that surrounds it. To put this life zone in perspective, imagine slicing through the solid earth like a cook slicing an onion in half and taking a look at the layered structure that lies beneath our feet. We know little about the internal structure of Earth thanks to the vibration caused by earthquakes, seismic waves which travel through the rock and are reflected and refracted by boundaries between different layers of rock in a way that is analogous to the way light is reflected and refracted from the surface of a block of glass. Just as physicists could work out some of the properties of the glass in a prism by shining light through it and studying the way it is refracted, so geophysicists work out some of the properties of the earth by monitoring seismic waves. But this is a very crude kind of X-ray process which depends on naturally occurring earthquakes to make the seismic waves, which are not under any sort of human control or having an array of seismic stations around the globe to monitor the seismic waves when they are produced. In many ways, we know more about the stars in the sky than we know about the center of the earth. After all, we can see the stars. The deepest that any person can get below the surface of the earth is to the bottom of the deepest mine, a mere 4 kilometers. And the deepest borehole ever drilled in the earth's crust reaches less than 20 kilometers below the surface. Although the details of the earth's gravitational and magnetic fields give some extra information about what is going on inside the earth, for the most part we are still dependent on those seismic waves. Why they show is a layered structure. What they show is a layered structure built around a solid inner core which has a radius of 1600 km. The exact radii that we quote here are all a little vague, reflecting the difficulty of making seismic observations. So don't be surprised if you see slightly different figures in different books. That this inner core is surrounded by a liquid outer core which has a thickness of dust over 1800 km. The whole core is very dense, probably rich in iron, and has a temperature of nearly 5000 degrees C. The circulation of this electrically conducting material in the liquid outer core is clearly responsible for the generation of the Earth's magnetic field, but nobody has ever been able to work out a completely satisfactory model of how this process works. The high temperature in the core is partly left over from the way the Earth formed as a hot ball of molten material made from very many smaller objects that collided or stuck together when solar system formed. More of this in chapter 9. Once a cool crust had formed round a molten ball of rock, it acted as an insulating blanket, trapping the heat within and only allowing it to escape slowly into space. Even so, without some continuing injection of heat, the interior of Earth could not still be as hot as it is today. More than 4 billion years later, the extra heat comes from the radioactive isotopes originally manufactured in the death throes of stars, which decay into stable elements and give out energy as they do so. In about 10 billion years' time, even this source of heat will be used up, and the earth will gradually cool down and freeze into one solid lump. But by then the earth itself will have died, so the freezing of the interior of the earth will be the least of the worries of any intelligent beings around to witness the event. The bulk of the home of the earth is made of a layer above the core, which is known as the mantle. The entire mantle is just under 3000 km thick, but is usually regarded as two components distinguished by slightly different seismic properties. The lower mantle about 2300 km thick and the upper mantle some 630 kilometer thick. Together they account for 82% of the volume of Earth and two-thirds of its mass. Above the mantle, like a skin around the solid Earth, is the crust. This is about 40 km thick under the continents of our planet, but only 10 km thick underneath the oceans.